So the last portion of this chapter, we're looking at how to name an acid. But before we get into naming an acid, we need to know what an acid is. So an acid produces hydrogen ions in water. Okay, and so that's the big thing. If I have HCl, AQ, so AQ stands for aqueous. That means it's been dissolved in water. So hydrogen and the AQ, that's kind of your indicators there. You have an acid. So hydrogen, AQ, that's, again, your indicator you have an acid because it's going to produce hydrogen ions in water. Okay. So the general formula is going to be HX, H2X, H3X, depending on which ion we're talking about. So HX, an example would be HCl. H2X would be H2SO4. And then H3X could be H3, whoops, supposed to be a 3, PO4. Okay, so these are examples of different acids with those formulas. Okay, so be careful, look for that AQ, because if you have HCl gas, a G, you don't have an acid, okay? And we name those differently, right? We've already talked about how we name those with the molecular compounds or the covalent compounds. It would be named hydrogen chloride, but if it's an AQ, right here, so AQ means you have the acid, G, you don't have an acid, okay? So I will be putting AQ next to your acid, so it will be pretty obvious what's an acid. Okay, so first we're going to name binary acids. So binary acids have hydrogen and an element. So there's one exception to that, but it's hydrogen and an element, okay? So binary acids are different than ternary acids. So circle hydro for me, okay, on your notes. Circle hydro, highlight hydro, because hydro is specific for binary acids. It tells us we have a binary acid. So we start off with hydro, then we add the root of our anion, and then we add ic, an acid. Okay, so here's our example down here. We start with hydro. Chlor is the root word for chlorine, and then ic, and then acid, hydrochloric acid. So you have to be careful because we do have a chloric acid, and it is not the same thing, okay? So again, hydro tells us we have a binary acid. You have to be careful there. Okay, so we can go from the formula to the name or the name to the formula. So let's do one from your, we'll do one from your worksheet, number 72, hydrobromic acid. Okay, hydrobromic acid. So hydro is not telling us we have hydrogen. The acid portion of the name is telling us we have hydrogen. So we always start with hydrogen, H+, because it's a +1, right? It's in group 1. And then bromic means we have bromine, which is Br, and it has a -1. So we do the switcheroo thing here, just like we do with ionic compounds. Oh, sorry, those are some terrible lines, or circle, whatever they are. Okay, HBr is our acid. Okay, you don't have to write AQ in your formula. You don't have to do that. I'm going to put them usually with the, I don't have them on 61, 62, 63 because I have them labeled as binary acids. But if it's not labeled like that, I will put the AQ there, okay? Okay, so before you move on to ternary acids, make sure you do 61, 62, 63, and 71, 72, 73. So there's not a whole lot of binary acids. Okay, ternary acids, we do not write the word hydro. Okay, so hydro. is not in this name. Put an X through it. Okay, no hydro here. Okay, with ternary acids, it's really important if you know your polyatomic ions because that's where we get the name, is from your polyatomic ion, okay? So here we have H2SO3. So let's first establish what is the polyatomic ion, SO3. So SO3 is sulfite, right? Sulfite. Ooh, I'm having trouble writing. Okay, sulfite. Okay, so up here it says ite turns into us. So what we're going to do is we're going to rewrite it and we're going to say sulfurous. So we're actually going to add a UR here. Sulfurous, and then we put acid at the end. Sulfurous acid is the name for H2SO3. So sulfur and, sulfate, we add the UR like that. Phosphorus, that comes from phosphate and phosphite. We add the little or. Okay, so those are the only two we do that. So that can be a little confusing. Okay, so here, next one, SO4 is sulfate. And we're going to change the ending. Okay, 8 goes to ic. So we're going to say sulfuric. So we're going to add that UR, sulfuric acid. And that's it. Okay, no hydro. Okay, now we can come down here. BRO, we saw earlier, was hypobromite. Okay, so we're going to change ite to us, and it becomes hypobromous. So we're not adding anything like we did with sulfate and sulfite. Hypobromous, and then acid. Okay, BrO2 is bromite. So we're going to go to bromite to bromous. Acid. Okay, BrO3 is bromate. And 8 goes to ic, so it's going to be bromic acid. Okay. And then BrO4 is this thing's in my way. Perbromic, or perbromate. Get out of my way. Sorry, perbromate. And it turns into perbromic acid. So you just have to change the ending of the polyatomic ion and then add acid. So that's why it's so important for you to know those polyatomic ions. So again, you can recognize them, know their name, and then change the ending and add acid. Okay, so the last part of your worksheet is 64 through 70 and 74 through 80. So these will be ternary acids. I just want to go do one. I'll come over here. From the name to the formula, because we just did formula to the name just now. So let's do nitric acid. We'll do number 74. Oops. 74 nitric acid. Okay, so we're going to go from the name to the formula. Okay, nitric came from nitrate. So nitrate is NO3 negative, and we have an acid, so we have hydrogen, right? So we do the switcheroo. It's just a 1-to-1. So we get HNO3. Okay, so again, I'll post the answers for this worksheet so you can check and make sure you did them correctly. And if not, you can talk to me and ask me questions, and we'll work through those, okay? But lots of practice for this naming portion. It seems to be the most difficult part of Chapter 2. That's why I've put a ton of worksheets for Chapter 2 so that you can get this down, okay? The more practice, the better.